The water here has never felt sunlight. Not really. At this depth, 600 meters below the surface of the Caribbean Sea, off the western edge of Cuba, the ocean becomes something different. It becomes ancient. It becomes dark in a way that daylight cannot touch, in a way that no storm above can reach. The pressure is absolute. The silence is complete. It was here, in the year 2001, that a team of ocean engineers pulled their sonar equipment across the seafloor and watched something appear on their screens that did not belong. The sonar image came slowly, the way truth sometimes arrives, one detail at a time, each one stranger than the last. Geometric shapes, right angles, structures repeating in regular patterns across an area of approximately 2 square kilometers. The kind of shapes that water does not make, the kind of shapes that stone does not arrange on its own, the kind of shapes that only one force in the known universe produces: deliberate, organized human intention. Paulina Zalitsky was not a woman given to dramatic conclusions. She was a trained ocean engineer, methodical and precise, the kind of professional who had spent decades studying what the ocean floor actually looks like when it behaves normally. She knew what sedimentary formations produce. She knew how geological processes arrange rock over millennia. And what she was looking at on that sonar screen was none of those things. Her team sent down a remotely operated vehicle, a machine built to go where human bodies cannot safely follow. The camera descended through the dark water, and the structures came into view in 3 dimensions for the first time. Not formations, not coincidences of geology. Massive granite and basalt blocks, cut at right angles, fitted together in patterns that extended in what appeared to be streets, corridors, elevated platforms, the skeleton of something that had once, in some distant and unnamed time, been a place where people lived and walked and built their world. The largest of these blocks weighs an estimated 200 tons. They are composed of granite and basalt stone types that do not form naturally in this part of the Caribbean. The seafloor here is limestone. To find granite here means it was brought. To find it cut means it was worked. To find it arranged in geometric patterns, fitting together across 2 square kilometers of seafloor at a depth where no human being has ever lived, means something that defies the architecture of the history we have been given. The dimensions alone are difficult to absorb. 2 square kilometers, 600 meters below the surface, hundreds of stone blocks weighing hundreds of tons each. This is not a collapsed cave system or an odd geological quirk. This is infrastructure. Zalitsky reported the discovery. She published the findings. She brought the footage forward for the world to examine. And the world, for the most part, looked away. That silence, not the noise of dramatic rejection, not the heat of academic controversy, but the quiet, systematic, institutional silence, is perhaps the strangest part of this story. Because what was found on the floor of the Caribbean Sea that year was, by any honest reckoning, one of the most extraordinary discoveries in the modern history of human exploration. And yet most people watching this right now have never heard of it. That is the question this documentary was built to ask. Not only what is down there, but why, in a world that claims to be endlessly curious about its own origins, does something this vast remain so quietly, so persistently, so deliberately unexamined? There is a version of human history that most of us were handed in school, and it goes something like this. For hundreds of thousands of years, human beings wandered the earth in small groups, hunting animals and gathering plants, living and dying without permanence. And then, roughly 5,000 to 6,000 years ago, something changed. People settled in the great river valleys, the Tigris and Euphrates, the Nile, the Indus, and civilization began. Cities rose, writing appeared. Mathematics was invented. Empires formed and fell. And from that moment until now, the human story has been one of continuous accumulation. More knowledge, more technology, more complexity building on what came before. It is a clean story. It is a satisfying story. It is a story with a clear beginning. It is also a story that has been revised, dramatically and repeatedly, every single time archaeologists have gone looking somewhere new. Heinrich Schliemann was told that Troy was a myth. It was a story Homer had invented, a poetic fiction with no basis in physical reality. In 1871, he dug at Hisarlik in modern Turkey and found it. Not one Troy, 9 layers of Troy, stacked on top of one another, evidence of a city that had been built and destroyed and built again across centuries that historians had not previously accounted for. Before the 1920s, the oldest known urban civilization was Sumerian, the city-states of Mesopotamia, pushing back to roughly 3,500 BCE. Then, archaeologists began excavating a series of sites along the Indus River Valley in what is now Pakistan and India. What they found changed the picture entirely. An urban civilization of extraordinary sophistication, cities with grid-planned streets, standardized weights and measures, an unbroken script that still has not been decoded, stretching back to at least 2,600 BCE, and with roots that reached further still. An entire civilization had been living and building and trading, while historians were not paying attention. And then there is Göbekli Tepe, discovered in Turkey in the 1990s. A complex of massive stone enclosures, carved with astonishing artistry, built by people who, according to the prevailing model of that era, should not have had the organizational capacity to build anything. Its construction predates the pyramids of Giza by 7,000 years. It predates Stonehenge by 6,000 years. It was built, according to the evidence, at a time when people were supposedly still wandering and gathering before agriculture, before cities, before everything we thought civilization required as a foundation. Each of these discoveries didn't just add information to the existing story, they restructured the story itself. Now consider a number, 120 meters. That is, approximately, how much sea levels rose globally at the end of the last ice age, between roughly 14,000 and 7,000 years ago. The ice that had locked vast amounts of water in continental glaciers melted, and that water returned to the world's oceans. The coastlines of every continent shifted dramatically inward. Low-lying plains became shallow seas, valleys drowned, river deltas vanished beneath the waves. The land that was lost was not marginal land. Coastal zones, by their nature, are among the most biologically productive, most climatically favorable, most easily habitable environments on Earth. They are where people settle. They are where civilizations begin near water, near food, near trade routes. And a strip of coastal land equivalent in total area to the entire continent of South America simply ceased to exist in geological terms in a remarkably short window of time. No archaeologist has ever excavated most of that land. No survey has ever fully mapped it. The question is not whether people lived there. Of course they did. The question, the one that the entire history of human civilization may hinge on, is what they built while they were there, and what happened to it when the ocean came. Every civilization we call ancient was discovered by someone who was first told they were wasting their time. The greatest discovery in human history may still be waiting not underground, but underwater. Of all the places on Earth where the ocean has swallowed a shoreline, the Caribbean is the one that holds its secrets most completely and most provocatively. The geography here is unlike anywhere else in the Atlantic world. The sea sits atop an underwater landscape of extraordinary diversity. Shallow banks that drop suddenly into walls of blue-black depth, enormous underwater plateaus that were once broad, fertile plains, ancient river systems whose channels can still be traced on the ocean floor, like the memory of waterways that haven't flowed in 12,000 years. The Yucatan Channel once carried the drainage of an enormous, well-watered landmass. The Gulf of Mexico was, in significant part, a freshwater basin, fed by rivers that no longer exist above sea level. The Bahama Banks today, a shallow underwater plain stretching across thousands of square kilometers, was once a highland tableland bigger than England, well-watered and warm, with precisely the conditions that would have made early human settlement not just possible, but likely. And sitting at the intersection of all of this, at the approximate moment of the last ice age's end, something else was happening. Something that geologists call the Younger Dryas. Roughly 12,900 years ago, global temperatures suddenly dropped, initiating a period of climate disruption that lasted more than 1,000 years before finally resolving into the warmer, more stable climate that allowed the familiar ancient civilizations to develop. What triggered the Younger Dryas is still debated. What it did to the coastal environments of the Caribbean is less ambiguous. It accelerated change, destabilized shorelines, and in concert with the rising seas, made the lowland Caribbean one of the most dramatically transformed landscapes in human prehistory. For any civilization established on those lowlands, the end would have come not gradually, but in waves, literal and figurative. A world going under. The reason we are only now asking these questions with serious technological capacity is simple. The ocean floor has been extraordinarily difficult to see. Less than a quarter of the world's seafloor has been mapped at high resolution. The tools that allow researchers to distinguish a natural rock formation from an ancient stone platform, multi-beam sonar, autonomous underwater vehicles, satellite altimetry have only reached the necessary maturity in the last 2 decades. The Caribbean, specifically, has been underexplored relative to its extraordinary archaeological potential, in part because deep-water research is expensive, in part because the sites that might be most significant are the hardest to reach, and in part because the academic framework for what to look for has, until recently, not included the possibility that there was anything to look for. That framework is changing. The questions are being asked now that were not asked seriously before, and the answers, in the water and in the sediment and in the stone, have been waiting with extraordinary patience. What follows is an account of what has been found, what it means, and why the ocean floor of the Caribbean may hold the most important unanswered question in the entire recorded history of human civilization. The history books say civilization began in the river valleys of the ancient world. The seafloor suggests the story began somewhere else entirely, and that the opening chapter was swallowed long before the first word was ever written down. Imagine standing at the edge of a map and watching the water drain away. Start with the Caribbean as it looks today, the turquoise shallows, the deep blue channels, the scatter of islands from Cuba to Trinidad, the great arc of the Lesser Antilles marking where the Atlantic meets the sea. Now imagine removing the water. Slowly, methodically, lowering the ocean level by 10 meters, then 50, then 100, then the full 120 meters that global sea levels have risen since the last ice age ended. What emerges from beneath the water is not a seabed, it is a lost world. The Bahama Banks, today a shallow underwater plain lying just a few meters below the surface in most places, become a broad, elevated tableland, rising well above the surrounding ocean. Its area, when the water is pulled back, is comparable in size to England. Its climate, in the warmer conditions of the late Ice Age, would have been semi-tropical warm, wet, with reliable rainfall feeding the springs and rivers that geologists can still trace in the underwater topography today. These are not hypothetical rivers. They are visible features of the ocean floor, ancient channels carved by flowing fresh water, sinkholes and blue holes that formed when limestone dissolved under the chemistry of surface rainfall, freshwater spring systems whose discharge points can still be detected on sonar surveys. These features do not form underwater, they form on land. They are the geological fingerprints of a time when this landscape was above the surface, breathing open air, feeling sun and rain. Cuba, as the water drops, extends dramatically westward. The shallow bank off its western tip, the same area where Paulina Zalitsky's team found their geometric stone structures, connects to a broader coastal plain, stretching toward what is now the Yucatan Channel. The Yucatan Peninsula itself, pulling the water back, reveals an extensive lowland region with river systems emptying into a coastline that once lay far from where it sits today. These river mouths, now submerged, would have been among the most fertile and productive coastal environments in the pre-flood Americas. River deltas concentrate nutrients. They support enormous ecological diversity. They are, historically, where agriculture begins, where populations concentrate, where trade routes form, where civilizations root themselves. Researchers who have applied bathymetric analysis to these now submerged river systems have found something quietly remarkable. The underwater topography in these areas is not the smooth, featureless sediment plain one might expect from 12,000 years of undisturbed submersion. There are elevated features at regular intervals. There are what appear to be terrace structures along ancient hillsides. There are formations that, when overlaid on what the landscape would have looked like at a lower sea level, fall precisely where a settlement-minded people would have built on higher ground near water, near the convergence of river systems, with long sightlines over a productive coastal plain. None of this is definitive proof of construction. Geology can arrange rocks in suggestive ways. The Caribbean seafloor is not exempt from that truth. But the cumulative picture that emerges from the bathymetric data is not random, it is coherent. It describes a landscape that, 12,000 years ago, would have been among the most attractive real estate on the planet for a coastal people with maritime skills and the knowledge of how to work with the land and sea together. The Bahama Banks specifically deserves attention not just for its size and its ancient fertility, but for the nature of the geological evidence preserved within it. The blue holes that punctuate the Bahamian seafloor are not mere curiosities, they are archives. The sediment, layers within them, record the environmental history of the region with extraordinary precision. Pollen from ancient vegetation, isotopic signatures of temperature and rainfall, organic material that can be dated by radiocarbon with reasonable accuracy. And what those sediment records show is a consistent picture. This was once a green and living landscape, well-watered, productive, exposed to the atmosphere. Not marginal territory. Not seasonal floodplain. Permanent, fertile, stable land, exactly the kind that attracts permanent, organized human settlement. The water covered it. The archive remains. And somewhere in the sediment and stone of that drowned tableland, the answer to a very old question may be waiting. The accepted story of how and when human beings arrived in the Americas has been revised more times in the last 30 years than in the entire preceding century of archaeological study. Each revision has pushed the date further back, the picture more complex, the original story less and less adequate. The Clovis model, named for the distinctive stone tools first found near Clovis, New Mexico, in the 1930s, held that the first humans in the Americas arrived roughly 13,000 years ago, crossing a land bridge from Siberia into Alaska during the last ice age, and dispersing southward through an ice-free corridor as the glaciers retreated. It was a clean and orderly story. It was also wrong, or at minimum, dramatically incomplete. By the 1990s, sites like Monteverde in Chile were demonstrating convincingly that people had reached the southern tip of South America before the land corridor through Canada was even open, which meant they had gotten there another way, most likely by boat along the Pacific coast. By the 2010s, the evidence had become extraordinary in its implications. In 2017, a study published in Nature presented findings from the Cerruti mastodon site in California, where the bones of a mastodon had been shattered and worked by what could only have been human tools, not 13,000 years ago, but 130,000 years ago. The scientific community received the finding with discomfort. To accept it would mean accepting that anatomically, modern humans, or a closely related hominin capable of purposeful activity, were in North America more than 100,000 years earlier than any accepted model could accommodate. The Caribbean enters this picture in ways that have received even less attention. Cave sites in Cuba and Hispaniola have yielded human skeletal remains and stone tools that push back occupation of the Caribbean island chain well beyond what the standard migration models comfortably allow. More significant still is what the DNA of ancient and modern Caribbean populations has begun to reveal. Genetic studies of the Taino people, the indigenous inhabitants of the Greater Antilles, encountered by Columbus in 1492, have found ancestry patterns that do not fit neatly into the expected migration pathways. There are genetic lineages in pre-Columbian Caribbean populations that point toward unexpected connections, markers that appear in populations along the Pacific coast of South America, others that suggest older and deeper ancestry than the island-hopping migration model can explain. There is a concept that archaeologists and population geneticists have begun to take seriously, sometimes called the coastal migration highway. The idea is straightforward. During the Ice Age, when sea levels were lower and the coastlines of the Americas were significantly more extensive, the coastal zones of the Caribbean, rich in marine food sources, warm, well-watered, would have been among the most attractive routes for movement and settlement. People following these coastlines, using boats as their primary mode of both travel and subsistence, would have left their traces not on the landscape that exists today, but on the landscape that now lies submerged. This creates a profound archaeological problem. The places where the earliest Caribbean inhabitants most likely lived, the coastal lowlands, the river mouths, the sheltered bays of what is now the Bahama Banks, and the Cuban Western Shelf are underwater. The evidence is not accessible through standard terrestrial survey. It requires exactly the kind of underwater investigation that has barely begun. What this means for the Taino is striking. These people, encountered by European colonizers as island dwellers, may not have been a people who arrived on the islands from somewhere else. They may have been a people who were pushed up onto the islands as the only remaining land, driven there by the rising sea from a homeland far larger and far older than any island chain. The islands were not the destination, the islands were the refuge. The origin was below them, in the water, in the stone, in the drowned plains that their ancestors had built upon before the world changed and the ocean took everything. What if the ancestors of the Caribbean's first known people were not the ones who arrived, but the survivors of the ones who were already there, pushed up from the drowned plains onto the islands that became their last refuge? The question of who they were begins with the question of where they came from, and that question leads directly to the seafloor. Every civilization eventually confronts the problem of permanence. Wood burns and rots. Mud brick dissolves under enough rain and enough time. Woven materials, bone tools, ceramic vessels, all of these things survive only under specific and often accidental conditions. But stone, dressed stone, stone cut and fitted and laid with intention stone, outlasts everything. It outlasts the people who cut it. It outlasts the language they spoke. It outlasts the name they gave themselves and the name their enemies gave them. In some cases, it outlasts entire chapters of the human story, persisting through epochs that erased every other trace of the civilization that built it. This was not accidental. The builders of the great megalithic traditions around the world understood, on some level, that stone was permanence made physical. The enormous limestone blocks of Baalbek in Lebanon, some weighing over 1,000 tons, the heaviest stones ever deliberately moved by human beings in history, were not shaped and transported because it was efficient. They were built that way because the builders wanted to make something that could not be easily unmade. The precision interlocking stones of Sacsayhuaman above Cusco in Peru, fitted together without mortar in polygonal arrangements so tight that a blade cannot be inserted between them, were not built that way because it was the simplest approach. They were built that way because the resulting structure is essentially earthquake-proof, and the builders knew it. The massive dolmens and standing stone configurations across Ireland, Britain, and Brittany were placed not by people with no understanding of effort, but by people with a very specific understanding of what they wanted to leave behind. The global distribution of megalithic construction is, itself, one of the more quietly remarkable facts of human prehistory. On every continent where human beings have lived for significant periods, there exist ancient stone structures built at a scale and with a precision that challenges the assumptions we make about the capabilities of the people who built them. Not all of these structures are connected. Not all of them belong to the same tradition. But they share a logic, and that logic is survival. Stone survives. Here is the question that logic implies for the submerged Caribbean. If a civilization existed on the fertile lowlands of the pre-flood Bahama Banks, the Cuban Western Shelf, the coastal plains of the Yucatan, a civilization sophisticated enough to organize the labor and knowledge required for large-scale construction, what would remain of that civilization after 12,000 years? Underwater? Not the wooden vessels, not the cloth, if they made cloth, not the organic matter of their daily lives, but the stone, the dressed, cut, deliberately arranged stone would survive. The ocean preserves what air destroys. Submerged in cold, low-oxygen water below the reach of surface storms, a stone structure can remain essentially intact for periods that dwarf the entire span of recorded history. The precise blocks would keep their corners, the alignments would hold. The carvings, if there were carvings, would remain legible to anyone patient enough to descend and look. The ocean floor is not a graveyard. It is an archive, and the possibility that it holds the preserved infrastructure of a civilization that built in stone, that organized its world around the sea, that lived and traded and perhaps flourished in the lowlands now covered by the Caribbean's blue water, that possibility is not dependent on imagination. It is dependent on the willingness to go down and look. The stage is set. The landscape has been reconstructed. The ancient inhabitants have been traced. The logic of stone has been established. Now, it is time to go down. The sonar doesn't lie. That is the thing about sonar. It is not a human interpretation, not an artist's rendering, not a theory about what might be there. It is a direct measurement of physical reality, a sound bounced off a surface and returned with information about shape, dimension, and depth. When Paulina Zalitsky's team ran their side-scan sonar across the seafloor off the western tip of Cuba in 2001, the data came back with the cold precision of an instrument that has no opinion about what it finds. What it found were rectangles, symmetrical configurations of geometric shapes distributed across 2 square kilometers of seafloor at a depth ranging from 600 to 700 meters. The sonar image does not show natural formations, it shows a pattern. Rectilinear blocks arranged in rows, features at regular intervals consistent with walls, platforms, or corridors. An area of artificial organization imposed on a natural landscape, visible even through thousands of years of sediment accumulation and biological growth. Zalitsky's team sent down an ROV, a remotely operated vehicle, essentially a camera on a cable, equipped with lights powerful enough to push back the absolute darkness of that depth. The footage that came back confirmed and expanded what the sonar had suggested. The blocks were not tricks of geology. They were three-dimensional, clearly cut at their corners, positioned in orientations consistent with planned construction. Some rose in tiered formations. Some ran in linear sequences that resembled roads or colonnades. Some bore surface features that appeared, to the researchers watching the footage, to be carved markings rather than the random abrasion of geological time. The stones themselves are the most scientifically significant aspect of the discovery, and the one most difficult to explain away. The seafloor of this region of the Caribbean is composed of limestone, the standard sedimentary rock of shallow tropical marine environments, formed from compressed organic material over millions of years. Granite does not form here. Basalt does not form here. These are igneous rocks, the product of volcanic and geological processes that do not occur in this part of the ocean floor. Yet the blocks in the Cuban complex are granite and basalt. To find these stone types in this location means they were transported, not created here, not exposed by erosion of existing seafloor geology, but brought from somewhere else, a quarry source that lies, given the composition of the rock, at considerable distance from the site. Then cut. Then moved, presumably by water given the logistics of the distances and weights involved. Then positioned with the geometric precision visible in both the sonar images and the ROV footage. The smallest reasonable estimate of the scale of this undertaking, if one accepts the human origin of these structures, is staggering. Moving a 200-ton block of granite across open water requires vessels capable of bearing extraordinary loads, organized crews operating with shared and detailed knowledge of seamanship, routes, and structural engineering, and a logistical infrastructure sophisticated enough to coordinate the effort across whatever period the construction required. This is not the behavior of scattered prehistoric bands. This is the behavior of a civilization. When Zalitsky reported these findings, the initial response was not dismissal, it was genuine interest. The BBC covered the discovery. New Scientist ran a piece. A handful of geological and archaeological institutions expressed cautious engagement. For a brief window, it appeared that the discovery might receive the intensive follow-up investigation it demanded. Then, the silence came. The specific critique most frequently leveled at the Cuban site is that the sonar images and even the ROV footage might represent a natural geological formation, perhaps a fault block, perhaps an unusual expression of underwater topography created by tectonic forces. This critique does not explain the granite and basalt on a limestone seafloor. It does not explain the right angles at the corners of the blocks. It does not explain why the distribution of features across 2 square kilometers maps so precisely onto what a planned settlement would look like. It explains away the interpretation, while carefully not engaging with the physical evidence. And in the decades since, no institution has funded a systematic excavation. No government has dispatched a deep-water research vessel to the site in any sustained, serious capacity. The site sits there, 600 meters below the Caribbean, in water too deep for casual investigation, too expensive for the independent researchers who have tried to follow up, and apparently too inconvenient for the institutions that might have the resources to do so. Something is down there. The sonar said so. The ROV said so. The geological analysis of the stone types said so. And the response of the established scientific world, not anger, not engaged refutation, but organized and enduring silence, is, in its own way, a kind of answer. In 1938, an American man named Edgar Cayce, who had no scientific credentials and no geological training, made a prediction. He said that evidence of the ancient lost civilization of Atlantis would be found in the waters near the Bahamian island of Bimini, and that it would be found around the year 1968 or 1969. This is the part of the story where a serious documentary is supposed to pause and distance itself from what follows. Cayce was a psychic, a figure whose methods and claims belong to categories that science neither verifies nor endorses. Mention his name in academic circles, and you will see people's faces close. And yet in 1968, almost exactly 30 years after his prediction, almost to the year, marine biologist J. Manson Valentine, snorkeling in the shallow waters off North Bimini, found something on the seafloor that he could not explain. What Valentine found, and what has since been examined, argued over, measured, photographed, and debated with extraordinary intensity for more than 50 years, is a formation of large, flat limestone blocks lying in 5 to 8 meters of water, forming what appears to be a curved, linear arrangement stretching approximately half a mile in length. The blocks are large, some approaching 5 meters in their longest dimension. They sit in remarkably regular rows, with a second tier of blocks visible beneath the first in areas where the sediment has been disturbed. The geological explanation offered by mainstream science is straightforward. The Bimini Road, as it came to be called, is a natural beach rock formation. Beach rock forms when carbonate sediment is cemented by calcium carbonate precipitation in the intertidal zone, a natural process that can produce flat, blocky slabs along a shoreline. Under this explanation, the Bimini Road is simply an unusual example of a known geological phenomenon, coincidentally shaped in ways that suggest human construction to the imaginative observer. The problem with this explanation is not that it's wrong on principle. Beach rock is real, natural formation can produce flat blocks. But the specific characteristics of the Bimini Road do not fit neatly into the natural beach rock model, and the researchers who have looked most carefully at the site have identified features that the geological explanation cannot account for. Dr. Greg Little and Dr. Joan Hanshaw spent years documenting the Bimini site with methodical precision. Their research found that some of the blocks in the formation are positioned in ways inconsistent with natural deposition specifically. Stones that appear to have been moved and repositioned, placed on top of smaller foundation stones rather than resting directly on the seafloor substrate. Beach rock does not do this. Natural processes do not stack large blocks on smaller ones for structural support. That is a construction technique. It implies planning, and planning implies builders. Little and Hanshaw also documented alignments between the Bimini Formation and specific stellar configurations that would have been visible from that location. At the time, the site would have been above water, somewhere between 5 and 10,000 years before the present. These alignments, if real, suggest that the site's orientation was intentional, chosen for astronomical reasons that imply a cultural sophistication far beyond what the natural formation hypothesis allows. But perhaps the most quietly explosive detail from the Bimini area is an artifact that has received almost no mainstream attention. A stone anchor, recovered from the seafloor near the road, whose construction style bears a strong resemblance to anchors used by Phoenician mariners in the ancient Mediterranean. Not a vague resemblance, a specific resemblance. The same shape, the same proportions, the same method of construction. If this anchor is accepted as authentic, it means that pre-Columbian visitors with Mediterranean maritime knowledge were operating in these waters, anchoring near a submerged structure of potentially enormous antiquity. That kind of connection between the Mediterranean and the Caribbean, between Phoenician seamanship and a submerged road in Bahamian waters, is the kind of connection that either rewrites everything or gets quietly set aside without follow-up. The history of the Bimini Road, like the history of the Cuban megaliths, is largely a history of the second option, and both of these sites, the deep Cuban complex and the shallow Bahamian road, sit at the edges of the same drowned plateau, the same sunken tableland, as if the ruins of something much larger lie scattered across the bottom of a world that used to be above the water. 30 years before anyone found it, a man with no scientific credentials predicted exactly where to look and then, almost to the year, it was found. The coincidence alone should have been enough to make the world pay attention. When scientists want to understand what a landscape looked like before something dramatic happened to it, they do not simply go and look, they reconstruct. They compile data from multiple instruments and multiple angles, overlay bathymetric surveys with geological analyses, model the effects of sea level change on terrain and drainage, and build, piece by piece, a picture of a world that no longer exists above the waterline. The tools available for this kind of reconstruction have improved enormously in the last 20 years. NASA's satellite altimeters can detect variations in sea surface height that reflect the gravitational pull of underwater terrain, essentially revealing the shape of the ocean floor by measuring the ocean surface above it. NOAA's multi-beam sonar programs have mapped significant areas of the Caribbean seafloor at resolutions that allow features of several meters to be clearly distinguished. And the data from these instruments, when combined and analyzed, produces something that has quietly unsettled a number of researchers who have looked at it carefully. The Bahama Banks, when examined through high-resolution bathymetric analysis, does not look entirely random. Across broad sections of this underwater plateau, there are linear features that do not correspond to any known geological process. Long, straight formations, running for considerable distances in orientations, inconsistent with the erosional and depositional patterns expected from natural sedimentation. Rectilinear shapes the same kind of right-angle geometry that made the Cuban sonar images so striking, appearing at scales large enough to be visible from satellite altitude. What appear to be channels running between elevated features in patterns that suggest drainage management rather than natural watercourse development. And in several areas, formations that resemble causeways, elevated linear structures connecting what would have been, at lower sea level, separate hills, or high points in an ancient landscape. Researchers who have specialized in applying landscape-level analysis to underwater terrain are careful about their conclusions. Satellite resolution at Bahamian depths cannot definitively distinguish human construction from an unusual geological formation. The honest answer is that the data creates questions rather than answers. But the questions it creates are precise and testable, and that is scientifically significant in itself. The pattern of anomalies across the banks is too consistent to dismiss casually. It is distributed across too wide an area to be explained by a single geological event. And when the features are overlaid on a reconstruction of the pre-flood landscape, when the water is removed and the terrain is seen as it would have appeared 12,000 years ago, many of them fall in positions that make immediate human sense. Elevated formations near ancient river confluences, linear features connecting high ground across what would have been valley floors, structures positioned with sightlines over broad productive lowlands. Independent researchers, working largely outside the frame of institutional archaeology, have spent years cataloguing these features and building the case that what the satellite and sonar data shows is the ghost of a large, organized pre-flood settlement pattern across the banks, not a single city, not a single site, but a landscape that was managed, inhabited, and built upon across a substantial area over a substantial period of time. When you zoom out far enough on a satellite map of the Bahama Banks, something strange happens. The ocean floor stops looking random and starts looking like a plan, like someone drew it. The data doesn't care about categories. The shapes on the ocean floor are there regardless of how they are labeled. And they keep asking the same question quietly, persistently, in satellite imagery and sonar returns from a world that went underwater before history learned to write anything down. Let's stay with the physics for a moment. Not the theory, not the mythology, not the question of what it all means, just the simple, unforgiving arithmetic of stone and water. A 200-ton block of granite. That is approximately the weight of 35 adult elephants. Or, to frame it differently, the weight of a fully loaded Boeing 737 aircraft twice over. Moving this object across flat ground, with modern machinery, cranes, flatbed trucks, hydraulic equipment designed specifically for the task, requires significant planning and significant infrastructure. Moving it across open water requires more. A vessel with sufficient displacement to float the load, a crew capable of managing the vessel under the weight, a route that accounts for weather and current, and a destination prepared to receive it. Now, remove the machinery, remove the hydraulics, remove the engineered steel cables, and the GPS navigation, and the diesel engines. Ask the question, how did people without these things move stones of this scale? The answer, interestingly, is that they did, repeatedly, on multiple continents, across thousands of years of documented and semi-documented megalithic construction. And the method they used, consistently and across cultures, was water. The builders of the Great Pyramid moved multi-ton limestone blocks from quarries at Aswan to the construction site at Giza, a distance of more than 800 kilometers, almost certainly by river barge along the Nile. The builders of Stonehenge transported the enormous sarsen stones from a quarry in Marlborough, approximately 25 kilometers away, across terrain that ancient Britons navigated in part by river and in part by sledge on prepared tracks. The builders of Tiwanaku in the Bolivian Altiplano moved enormous sandstone blocks across Lake Titicaca on reed boats, capable of bearing loads that still impress modern maritime engineers. In every significant case of large-scale megalithic construction, the research eventually circles back to the same conclusion. The heaviest things were moved on water, because water bears weight more efficiently than any land-based system available to pre-industrial technology. This creates a remarkable implication for the Caribbean structures. If the civilization that built them was maritime, if the ocean was their home, their highway, their trade network, for their primary medium of movement through the world, then the logistical challenge of moving enormous stones across water was not an extraordinary feat requiring exceptional circumstances. It was the baseline. It was what they did every time they needed to move anything heavy from anywhere to anywhere else. For a seafaring people, the ocean is not a barrier to construction. It is the construction infrastructure. A 200-ton granite block on the appropriate vessel in calm Caribbean waters, guided by navigators who had spent their entire lives reading currents and stars, was not an impossible challenge. It was a specialized version of the same task they performed routinely for trade, for communication, for subsistence. This reframes the Cuban discovery in a critical way. The question should not be, how did these people move 200-ton stones across the ocean? That question assumes the stones were the exceptional part. The question should be, what kind of people had the maritime infrastructure that made moving 200-ton stones across the ocean the straightforward part of the problem? The answer is, a civilization whose primary domain was the sea. A civilization that built its social organization, its economy, its knowledge systems, and its physical infrastructure around mastery of the water. A civilization for whom a coastline was not the edge of the world but the center of it. Every ancient culture that we know produced megalithic construction was also a culture with significant water access and significant boat-building capability. This is not coincidence. It is engineering logic. The largest block in the Cuban underwater complex weighs roughly 200 tons. It is made of granite. There is no granite quarry within 500 kilometers. Someone carried it and then cut it so precisely that it still sits in perfect alignment 12,000 years later. There is a difference between big and precise. Bigness alone proves only that a lot of material was gathered and deposited in one place. Precision proves something else entirely. Precision proves thought. The stones of the Cuban underwater complex are both big and precise. The right angles at their corners deviate from 90 degrees by margins, measurable in fractions of a degree, a level of accuracy that, even with modern instruments, requires careful calibration and deliberate technique. The flat surfaces of the blocks show, in the areas where ROV cameras have captured sufficient detail, marks that researchers describe as consistent with tool use on a hard stone surface, not the random scratching of water erosion or the patterned abrasion of sand movement, but the directional marks left by a cutting edge moving systematically across stone. After 12,000 years submerged in Caribbean water, exposed to biological growth and sediment, these marks persist. The stone remembers the tool that shaped it. This matters in a specific and measurable way. The mathematical precision required to cut a stone to exact right angles, to produce flat surfaces within tolerances of a fraction of a degree, to cut multiple blocks to compatible dimensions that allow them to be assembled into a larger structure. This precision is not the product of casual effort. It requires a measuring system, a standard, an agreed unit of dimension that is applied consistently across the cutting of every stone in the structure, so that when the blocks arrive at the construction site, they fit. This is not intuitive. It is learned, taught, refined over generations, and embedded in the culture of the people who practice it. Researchers who have studied the dimensional characteristics of megalithic structures worldwide have found something that resists easy explanation. The same measuring standards appear, with remarkable consistency, in ancient stone structures on multiple continents that were supposedly built by unconnected cultures in different eras. John Neal's extensive work on what he calls the ancient module, a family of related units of measurement that cluster around the same approximate dimensions and their rational subdivisions, has identified this standard in the dimensions of the Great Pyramid at Giza, in the layout of Stonehenge, in the megalithic yard used by Neolithic builders across northwestern Europe, and in the proportions of structures in Peru and Mexico. These are not identical measurements. They are related measurements, variations on a theme, the same underlying logic applied in locally adapted forms. The symbols are more startling still. Among the features documented in the Cuban underwater site are carvings on several of the stone surfaces, geometric marks that appear to have been deliberately incised rather than naturally produced. These markings have not been decoded. They have not been formally published in a comprehensive study, but they have been photographed and observed, and among the researchers who have examined them, something troubling has been noted. Some of these marks bear a close resemblance to symbols found in the script of the Indus Valley Civilization, the as-yet undeciphered writing system used by the urban cultures of ancient Pakistan and northwest India between approximately 2600 and 1900 BCE. Two civilizations, two oceans, the same marks. The Indus Valley and the Caribbean are separated by the breadth of the earth. There is no accepted model of ancient contact between them. There is no mechanism within the conventional historical framework by which a symbol system in one place should appear in the stonework of the other. And yet there it is, captured in photographs, sitting on the ocean floor 600 meters below the Caribbean, waiting for someone to sit down with the patience and the funding and the intellectual courage to ask why a mark made in ancient India appears on a stone that should not be where it is, in water that should contain nothing but empty seafloor, telling a story that the accepted history of human civilization has not yet learned to read. The precision of the stonework is not background information, it is the message. Stone cut this carefully speaks a language, and the language it speaks suggests a connection that runs far deeper and far earlier than any map of human history has ever shown. The earth keeps records that human beings do not. Long before writing existed, long before memory could be passed from generation to generation in reliable form, the planet itself was documenting what happened to it, layer by layer, crystal by crystal, in the slow and patient language of geology. An ice core drilled in Greenland captures the atmospheric chemistry of every year, going back hundreds of thousands of years, preserved in bubbles of ancient air trapped in the ice as it froze. A coral formation records sea surface temperatures in isotopic signatures readable to within a degree. A speleothem, the mineral formations that grow inside caves, built drop by drop from mineral-laden water, encodes rainfall patterns, temperature variations, and atmospheric changes in its banding structure, with a precision that rivals any human instrument. The Earth is not indifferent to its own history. It writes it in every layer it deposits, in every crystal it grows, in every sediment it compresses. And the geological record, when read with modern instruments applied to cores and samples from across the planet, tells a story about the end of the last ice age that is both detailed and disturbing. Sea level rise at the end of the ice age was not a smooth and gradual process. The geological record shows episodes of sudden acceleration events that geologists call meltwater pulses, the most dramatic of which occurred approximately 14,000 years ago, and again around 11,000 years ago. During these pulses, sea level rose at rates estimated at up to 4 meters per century. Not the millimeters per year of contemporary climate concern, but meters per lifetime. Coastlines shifting inward across tens of kilometers within the lived experience of a single human generation. For any civilization established in the Caribbean lowlands, these pulses would have been events of unmistakable catastrophe, the ocean advancing faster than relocation could keep pace, swallowing land, harbours, buildings, entire communities. This geological reality arrives in the historical record, wearing a different name. Every major ancient culture on Earth has a flood story. The Sumerian Epic of Gilgamesh, one of the oldest written texts ever found, contains a flood narrative in which a great builder constructs a vessel to survive a world-destroying deluge. The Hebrew Bible's account of Noah follows the same template. The Hindu Matsya Purana describes a god who warns a sage of an imminent flood and instructs him to build a boat. The Maya Popol Vuh describes the destruction of a previous race of humans by a great flood. The Taino creation mythology includes a flood that drowned the world before the current one. Indigenous cultures from the Andean coast to the Pacific Islands carry variations on the same essential narrative. Water coming, everything lost, a few survivors carrying the memory forward. The conventional interpretation of these stories is that they represent independent mythological expressions of a universal archetype. The fear of natural disaster encoded in narrative form. But there is another interpretation, one that geology now lends significant support to. These stories are memory. They are the preserved testimony of real events, encoded in the most durable medium that pre-literate cultures had access to story, passed from generation to generation, with the conscientiousness of people who understood that what they were carrying mattered. The Maya had a flood myth, the Caribbean islanders had a flood myth, the ancient Sumerians had a flood myth. Geologists can now tell you exactly when the flood happened, and it matches. When geologists can place the catastrophic sea level rise at precisely the moment the myths describe, the coincidence becomes harder to dismiss as coincidence. The myths are not poetry. They are testimony, the recorded experience of people who watched the water come and never forgot that it did. What came before the water is what the rest of this story is about. They have no name. That is the first and most disorienting fact about them. Every other civilization in human history that we consider significant, Sumerian, Egyptian, Mayan, Minoan, Harappan, carries a label, a point of reference, a cultural address in the library of human knowledge. The civilization that may have built the Caribbean megaliths, that may have navigated the Atlantic and taught the ancient world the mathematics encoded in stone, exists only in traces, in bones that tell stories their owners never wrote down, in DNA that carries signatures of journeys no map recorded, in myths whose original tellers have been gone for 12,000 years. Building a portrait from traces is the essential work of archaeology. It is the patient act of inference, taking what survives and reasoning toward what does not. Applied to the Caribbean's pre-flood civilization, this process draws from 4 different categories of evidence, and the portrait that emerges from each of them is, with striking consistency, the same portrait. Genetically, the picture begins with anomalies. Studies of ancient DNA extracted from pre-Columbian, Caribbean and Mesoamerican populations have identified haplogroups' genetic lineages that do not fit cleanly into the accepted models of American population. History. The standard model holds that the Americas were peopled entirely by migrants from Northeast Asia, crossing the Bering Land Bridge, and that any modern genetic diversity in the Americas reflects secondary movements within the continents after that original crossing. But the data keeps producing complications. There are markers in ancient Caribbean populations that appear in South Asian populations. There are lineages in coastal Mesoamerican populations that suggest ancient connections to West Africa. These are not dominant genetic signatures, they are minority threads in complex ancestry patterns. But they are there, confirmed by multiple independent genetic studies, and they have not been satisfactorily explained by any model that limits ancient Atlantic contact to the period after Columbus. Linguistically, the evidence is subtler, but no less suggestive. Comparative linguists who have studied the root structures of Carib and Arawak languages, the language families of the indigenous Caribbean, have noted parallels with Dravidian languages of southern India, and with certain root patterns in Proto-Indo-European that are difficult to account for through chance or through the normal processes of independent linguistic development. Languages share roots when populations share ancestry or sustained contact. The parallels noted in Caribbean linguistics do not prove contact, but they constitute a question that deserves more serious investigation than it has received. Mythologically, the convergence is the clearest of all, because mythology preserves cultural memory in its most concentrated form. The creation stories of the Taino describe the ancestors emerging from caves and from beneath the water, not descending from the sky or arriving from distant lands, but rising from a submerged place, a world that was once below. The Maya Popol Vuh's account of the creation of the current world explicitly involves the destruction of earlier peoples by flood. Among the indigenous peoples of Cuba and Hispaniola, oral traditions collected by early ethnographers include descriptions of ancestors who built great stone cities, who understood the movements of the stars, and whose civilization was ended by the ocean. These are not peripheral folkloric details. They are the central narratives of origin that these cultures have carried and defended for as long as their cultural memory reaches. And across all of these traditions, genetic, linguistic, mythological, the portrait that emerges is the same: maritime people. People for whom the ocean was home, highway, and cosmological center. Builders who worked in stone because they understood that stone lasted. People with a knowledge of the sky precise enough to navigate the open ocean and orient their constructions with astronomical accuracy. And a civilization that ended not gradually, not through conquest or internal collapse, but through a catastrophe involving water. The Taino did not call them gods. That detail matters. Many ancient cultures explain a predecessor civilization by making them divine, by placing them outside human time and human capability, safely beyond the need for historical explanation. The Taino called them the Ancient Ones. The Maya's Popol Vuh describes the people before the flood as builders of human flesh and human aspiration, not supernatural creatures. The ancestors were people. They were here, they built, and the sea took them. Every culture that lived near the Caribbean remembered them. None of them called them gods. They called them ancestors, and in that quiet word, the entire weight of 12,000 years of loss is carried forward. Mainstream archaeology has a quiet problem with transoceanic contact before Columbus. It is not that the evidence does not exist. There is more of it now than at any previous point in the history of the discipline. The problem is that the evidence does not fit the model. And when evidence does not fit the model, it tends to be explained away, one piece at a time, each anomaly addressed in isolation, without anyone standing back to ask what it means that there are so many anomalies pointing in the same direction. The cocaine mummies are the most famous and most inconvenient of these anomalies. In 1992, German toxicologist Svetlana Balabanova analyzed tissue samples from Egyptian mummies and found the chemical signatures of cocaine and tobacco in the mummy tissue. Cocaine is derived from coca, which grows only in South America. Tobacco, in the forms detectable in the tissue, was also a New World plant. These were Egyptian mummies, dated to approximately 1000 BCE, more than 2,000 years before Columbus. When Balabanova published her findings, the response from Egyptology was dismissal. Contamination, she was told. Methodological error. The results were impossible, therefore they must be wrong. Subsequent independent testing by different laboratories using different methodologies confirmed the original findings. The mummies contained New World plant derivatives. The standard explanation that this cannot have happened has never been replaced with an explanation for how it did. The Olmec colossal heads of Mesoamerica present a different kind of anomaly. These massive carved stone portraits, created by the Olmec civilization of coastal Mexico between approximately 1500 and 400 BCE, depict faces that a significant number of physical anthropologists have described as displaying distinctly West African morphological features: broad nasal structures, full lips, facial proportions that differ markedly from those of other Mesoamerican peoples. The mainstream response, again, is that this is coincidence, that the sculptors were representing local phenotypes, and that the resemblance to West African features is an artifact of interpretation. This response would be more satisfying if there were not also, in the same pre-Columbian Mesoamerican cultural context, inscriptions that some researchers have identified as being in a West African script. The temples of Hoysala in southern India, built between the 11th and 14th centuries CE, include sculptural panels depicting plants in their decorative carvings. Among these carvings, botanical historians have identified what appear to be representations of corn, a plant that is unambiguously a domesticated species of Central America, unknown in Asia until after Columbus. The Hoysala temples predate Columbus by centuries. They should not contain images of corn. They appear to contain images of corn. The explanation most commonly offered is misidentification. This explanation might suffice for a single example. It becomes strained when the same observation is made across multiple temple sites by multiple independent botanical historians. The sweet potato, however, is not subject to any of this ambiguity. Genetic analysis of the sweet potato, published in a peer-reviewed study in 2013 and confirmed by subsequent research, demonstrates conclusively that the crop spread from South America to Polynesia at least 1,000 years before European contact. This is not a contested finding. It is not disputed on methodological grounds. It is accepted by mainstream anthropology, evolutionary biology, and genetics. Someone was crossing the Pacific Ocean at least 1,000 years before the first European ship sailed those waters, carrying domesticated crops from one side of the world to the other, with sufficient frequency that the crop became established across a vast geographic range. If that was happening in the Pacific, systematically and before Columbus, what was happening in the Atlantic? The Atlantic is narrower. Its current patterns, the equatorial currents that flow westward toward the Americas, and the North Atlantic gyre that flows back eastward are, if anything, more naturally suited to round-trip voyaging than the Pacific routes. Researchers found cocaine in an Egyptian mummy. Not once, many times, across multiple mummies, confirmed by multiple independent labs. Cocaine is made from coca leaves. Coca leaves grow only in South America. Someone was crossing the Atlantic 3,000 years ago, and they were not the first. The evidence of Atlantic contact exists. It keeps being found. The model that says it cannot have happened grows harder to defend with each new discovery, and the sweet potato provides the anchor of certainty from which all other questions can be asked. There is a man who can navigate across 1,000 kilometers of open Pacific Ocean without a compass, without a GPS receiver, without any instrument at all. He uses the stars. He reads the swells, the deep, long swells that carry the signatures of distant land masses and storms hundreds of miles away. He watches the behavior of birds. He feels the temperature of the water on the back of his hand and interprets what it tells him about his latitude. He knows the angle at which specific stars rise and set for specific locations, and he uses those angles as a moving compass that works in any direction. His name is Mau Piailug, and he is a master navigator of the Carolinian tradition of Micronesia, a tradition of wayfinding that has been practiced without interruption for an estimated 2,000 years, allowing Pacific Islander populations to colonize the most remote islands on the planet with deliberate accuracy, not by accident of drift, but by systematic knowledge of the sky, the sea, and the wind. Mau Piailug's skill is not an anomaly. It is the normal inheritance of a people for whom the ocean is not a barrier but the medium of existence. And it is a direct demonstration of something that gets lost in the conventional framing of ancient seafaring, the assumption that without instruments, navigation across open water was unreliable, dangerous, and unlikely to produce sustained, directed travel across significant distances. The opposite is true. Star-based navigation, when mastered, is more reliable than any mechanical compass in consistent conditions, because the stars do not malfunction. They are consistent across millennia. The positions of stars at their rising and setting the angles they make with the horizon for specific latitudes do not change on timescales of centuries or even thousands of years. A navigator who learned the star paths of the Caribbean and Atlantic basin 2,000 years ago was using the same sky that a navigator 10,000 years earlier had used. The sky is the oldest and most durable map in existence. The evidence that ancient cultures possessed sophisticated astronomical knowledge is not limited to Pacific Islanders. The architectural alignments of Mayan temples encode the solar cycle with extraordinary precision. The twice-yearly alignment of light and shadow on the steps of El Castillo at Chichen Itza, descending like a serpent on the equinox, is not an accident of construction. It is intentional design, requiring an understanding of the solar year more accurate than the Julian calendar that Renaissance Europeans were still using centuries later. The astronomical alignments encoded in the orientation of the pyramid field at Giza, in the stone circles of Britain, in the ceremonial architecture of the Mississippian mound builders, these are not isolated curiosities. They are evidence of a widespread, sophisticated, and deeply invested relationship between ancient human cultures and the movements of the sky. Researchers studying the alignments of the Bimini Road have noted that its orientation corresponds with a precision that suggests intention to the rising positions of specific stars, as they would have appeared from that latitude several thousand years before the present. If confirmed, this would mean that the Bimini Formation is not merely a structure, it is an oriented structure, placed with deliberate reference to the sky, in the manner of virtually every other major ancient monument whose alignment has been carefully studied. Before the compass, before the sextant, before paper, ancient sailors were crossing thousands of miles of open ocean guided by nothing but the sky, and they were doing it so accurately that their navigational knowledge still works today. A civilization that knew the sky well enough to build this way, well enough to navigate the Atlantic with the reliability that the transoceanic contact evidence implies, was not a culture operating at the edge of capability. It was a culture for which astronomical knowledge was foundational, embedded in architecture, navigation, religion, and the organization of time itself. And if it existed in the Caribbean lowlands, its mastery of the sky was not a late achievement. It was the earliest, most essential thing it ever built, and it radiated outward to every culture that came after, encoded in the stone alignments and the star stories of 100 ancient peoples who remembered where their knowledge came from, even after they forgot the name of the place it originated. The word empire carries baggage. It arrives trailing images of armies and conquered provinces, of tribute paid under threat of violence, of one culture imposing its language and its gods on another by force. This is one kind of empire, the kind history has documented most extensively, because it tends to leave dramatic physical evidence and to generate the kind of conflict that gets recorded in the archives of the victors. But it is not the only kind. Consider the Phoenicians. This Semitic people, based in the cities of what is now Lebanon, built the most extensive maritime trade network the ancient Mediterranean world had ever seen without fielding an army capable of challenging any of the major powers of their era. At their height, the Phoenicians had established trading colonies and way stations from the coast of Lebanon all the way to the Atlantic coast of Spain and Morocco. Their ships carried tin from Cornwall in Britain, silver from Iberia, purple dye from their own coast, glass from their manufactories, and luxury goods from the edges of the known world. Their alphabet became the foundation for Greek, and through Greek for Latin, and through Latin for every alphabet used by Western civilization today. Their navigational knowledge, jealously guarded, deliberately kept from rivals, allowed them to sail routes that other mariners could not follow, to trade in goods that other merchants could not source, to maintain a commercial empire whose power rested entirely on the simple advantage of knowing where things were and how to get there. No Phoenician army conquered Rome. No Phoenician emperor demanded tribute from Persia. And yet the Phoenicians shaped the ancient world more profoundly than most of the military empires that are remembered with more drama. They did it through the control of knowledge specifically, maritime knowledge, the most valuable strategic resource of the ancient world. This is the model that makes the forgotten Caribbean civilization comprehensible. Not a political empire, not a military state. A maritime knowledge empire, a civilization whose power, reach, and influence derived from the fact that its people knew the ocean in a way that no other contemporary culture did. They knew the currents that would carry a vessel from the Caribbean to the African coast without constant rowing. They knew the star paths that would bring a navigator back across the Atlantic with reliable accuracy. They knew where the raw materials of civilization were located, the metals, the agricultural products, the biological resources that other cultures needed and could not reliably obtain. And they controlled the routes that connected these resources to the people who wanted them. Under this model, the submerged structures of the Cuban shelf and the Bahama banks are not the ruins of a capital city. They are nodes in a network, ports, way stations. The physical infrastructure of a maritime system that connected the Atlantic world before the Atlantic world knew it was connected. An empire of this kind does not need to plant its flag in foreign capitals. It needs only to be present where the ships stop, where the cargo changes hands, where the knowledge of the next leg of the voyage is exchanged. The physical footprint of such an empire would be exactly what is being found. Stone-built harbours and platforms in locations of maritime strategic significance, distributed across the key nodes of a pre-flood Atlantic trade network, preserved in the only medium that survives everything stone on the ocean floor, patient and silent. History's most powerful empires have not always been the ones with the largest armies. Some of the greatest powers in human history ruled not through fear, but through the simple fact that they knew where everything was, and everyone else did not. The history we were taught did not have a category for this kind of civilization. That absence of a category does not mean the category does not exist. It means we have not yet built the vocabulary to describe what we are finding. If a teacher civilization existed, if there was a source from which multiple ancient cultures inherited their mathematical knowledge, their building techniques, and their astronomical frameworks, the evidence of that teaching should be detectable as a shared signature, not identical buildings, not copied inscriptions, but a common underlying grammar. The way that languages descended from the same ancient root share word patterns and grammatical structures, even when they have evolved into mutually unintelligible forms. When researchers look for this kind of architectural and mathematical grammar across the ancient world, they find it, and the pattern they find is disturbing in its consistency. Polygonal interlocking masonry, the technique of fitting irregularly shaped stones together, without mortar, each stone cut to match its neighbors, precisely appears in the monumental architecture of ancient Peru, in the foundations of certain structures at Giza, in the walls of Mycenaean citadels in Greece, in the fortifications of ancient Japan, and in the submerged Caribbean structures documented by researchers examining the Cuban and Bahamian sites. This technique is not simple. It requires more cutting and more planning than standard rectangular block construction. A builder using this method must cut each stone to fit its specific neighbors, meaning the entire structure must be planned in 3 dimensions before a single cut is made. Cultures separated by oceans and thousands of years did not independently invent this unnecessarily complex technique. Someone either taught it to all of them, or they all inherited it from a common predecessor. Corbelled, vaulting the technique of building an arched space by progressively stepping stones inward until they meet at the center, creating a stable vault without the need for a true arch, appears in the ceremonial architecture of Mesoamerica, in the passage tombs of Neolithic Ireland, and in the ancient structures of the Cycladic Islands in the Aegean. These cultures were not in contact with each other within the conventional framework. They shared a structural technique nonetheless. The measurement problem is perhaps the most mathematically compelling of these parallels. Researcher John Neal's meticulous analysis of ancient measurement standards found that a family of related units, all derivable from each other through simple rational fractions, appears in the dimensions of megalithic structures on multiple continents. The English foot, the Greek foot, the Roman foot, the Indus Valley unit, the megalithic yard of Neolithic Britain. These are not accidental convergences. They are members of the same measurement family, derivable from each other by fractions of small integers, in a way that is statistically impossible to explain as independent invention. Most striking of all is the encoding of geographical data in monument proportions. The Great Pyramid at Giza, when its dimensions are analyzed, appears to encode the circumference of the Earth specifically. The ratio of its perimeter to its height reproduces the ratio of the Earth's circumference to its polar radius to within a fraction of a percent. The precision required to achieve this, accidentally, is essentially 0. The precision required to achieve it deliberately requires a knowledge of the Earth's actual shape and dimensions that, according to the conventional history of science, was not achieved until the work of Eratosthenes in the 3rd century BCE, 2,000 years after the pyramid was built. The same measurement system was used to build the Great Pyramid in Egypt and temples in ancient Peru. The cultures were separated by an ocean. They had no contact, supposedly, but they used the same ruler. Someone taught them both. The simplest explanation, the one that does not require coincidence to be multiplied indefinitely, is that there was a source. A civilization, or a succession of civilizations, that possessed this mathematical and geographical knowledge, and distributed it across the ancient world through the only reliable mechanism of knowledge transfer that existed before writing: direct contact, teaching. The personal transmission of technique from master to student across the sea routes that connected the ancient world. A civilization that lived on the sea would have been exactly positioned to do this. And if that civilization's homeland now lies beneath the Caribbean, its teaching lives on in the stones of 100 ancient cultures that still do not know where the knowledge came from. 12,900 years ago, the world ended. Not for everyone, not completely, but for any civilization established in the fertile lowlands of the Atlantic coastal world. What happened next was as close to extinction as it is possible to come and still leave traces for the future to find. The evidence for this event does not come from mythology, though mythology records it with consistency across cultures. It comes from the ground specifically, from a thin, dark layer of soil found at sites on 4 separate continents, including multiple locations in North America, Europe, and the Middle East, all dating to the same moment, approximately 12,900 years ago. This layer contains things that are not normally found in ordinary soil deposits. It contains nanodiamonds, microscopic carbon structures that form only under the extreme heat and pressure of a high-velocity impact. It contains platinum group elements at concentrations far above background levels, the same elements found in elevated concentrations at the sites of known meteorite impacts. It contains microspherules of glass formed by the instantaneous melting of rock at temperatures consistent with a cosmic impact event. This black mat, as it has come to be called, appears consistently in the geological record, at the boundary between the Pleistocene and Holocene epochs, the exact moment at which the last ice age ended. The climate dramatically shifted, and the Laurentide ice sheet began its catastrophic collapse. The Younger Dryas impact hypothesis, first proposed in a landmark 2007 paper, argues that this evidence represents a cometary or asteroidal impact event, or possibly multiple impact events from a fragmented object that triggered a cascade of consequences. Firestorms across vast areas of the northern hemisphere, the destabilization of major ice sheets, the injection of enormous quantities of meltwater into the North Atlantic, and a resulting disruption of ocean circulation patterns that caused global temperatures to drop suddenly and dramatically before the final warming that ended the Ice Age. The hypothesis has been contested, as any paradigm-challenging proposal is contested, but the evidence supporting it has only grown since 2007. Over 50 peer-reviewed papers from research teams on multiple continents have confirmed the presence of the impact markers in the black mat layer. The hypothesis is no longer the fringe proposition it was when first introduced. It is a matter of active scientific debate, and in that debate, the weight of physical evidence has been consistently accumulating on one side. For a civilization in the Caribbean lowlands at this moment, the consequences would have been sequential and inescapable. The initial impact, or impacts, wherever they struck, would have generated tsunamis capable of traversing entire ocean basins. The firestorms across North America would have altered the climate of the entire Atlantic region within days. The collapse of the Laurentide ice sheet would have released a pulse of cold fresh water into the North Atlantic so massive that it disrupted the thermohaline circulation, the ocean current system that regulates the climate of the entire northern hemisphere for 1,000 years. And beneath all of this, inexorably and permanently, the rising sea would have followed, swallowing the lowlands meter by meter over the generations that followed. There is a layer of black soil found in the ground on 4 continents at the exact same moment in time, 12,900 years ago. In that layer, evidence of fire, evidence of impact, evidence of catastrophe, and then above it the world that we know. The flood myths are the testimony of survivors. Not one flood, a series of them, triggered by a cosmic event so catastrophic that every culture in the world that had any people left after it remembered it forever. Gilgamesh and his ark, Noah and his, the Mayan peoples before the flood who were washed away and replaced, the Taino ancestors who came up from below the water. They were not writing poetry. They were writing history. And the history they were writing ended the day the empire ended, and the ocean took everything that was not made of stone. The Caribbean is not alone. Off the southwestern coast of Japan, in 25 meters of water near the island of Yonaguni, there is a structure. It was found in 1986 by a dive instructor exploring a known site for hammerhead sharks. What he found beneath the hammerheads was something that did not belong in the natural underwater topography of this region of the Pacific. A series of massive stone platforms, precisely stepped like a monumental staircase, with flat vertical faces, right-angle corners, parallel edges, and what appear to be deliberately carved grooves running along its surfaces. The Yonaguni monument has been examined by marine geologists, who argue that its features can be explained by natural fracturing of sandstone along existing joint planes, and by researchers who counter that, while each individual feature might have a natural explanation in isolation, the combination of so many features in such a concentrated and organized arrangement is not what natural fracturing produces. The debate continues. The structure remains neither confirmed nor dismissed. Off the northwest coast of India, at the head of the Gulf of Khambat, oceanographers conducting a routine survey in 2002 made a discovery that the Indian government announced with considerable excitement. Sonar surveys of the seafloor revealed an extensive underwater complex submerged to approximately 40 meters that bore the organizational characteristics of urban settlement. Geometric shapes, linear features consistent with walls and streets, and an overall spatial pattern inconsistent with natural formation. Artifacts were recovered from the site, including worked wood and pottery, and the wood was radiocarbon dated to approximately 9,500 years before the present, thousands of years before any recognized civilization in the Indian subcontinent. If the dating is accurate, the Gulf of Khambat site would represent the oldest known urban complex in human history. Off the Atlantic coasts of Spain and Portugal, megalithic structures have been documented that were clearly built when the sea level was significantly lower, dolmens and stone alignments now partially or fully submerged, positioned in ways that only make sense if the ocean was not where it is today when they were built. Off the coast of Sicily, stone circles and platforms have been found in shallow water whose construction predates the current coastline. Off the Azores and the Canary Islands, enigmatic stone walls and formations have been documented on the seafloor and on the submerged slopes of what were, at lower sea levels, much larger islands. Each of these sites, in its own regional context, presents the same challenge. It implies that the area where it sits was above water, inhabited, and built upon by people with the organizational capacity and technical knowledge for monumental construction at a time before our accepted timelines allow for such civilizations to have existed in those regions. Japan has one, India has one, the Mediterranean has one, the Atlantic has multiple. Every major ocean in the world has a submerged site that the mainstream has struggled to explain. What if they are not separate mysteries but chapters in the same story? Taken individually, each site can be questioned, debated, explained away. The tools of academic dismissal work on single data points. But the global distribution of these discoveries defeats the individual approach. There are too many of them. They are too geographically diverse. They appear in every major ocean, on every coastline that was significantly affected by the sea level rise at the end of the Ice Age. They are not isolated mysteries. They are chapters in the same story, the story of a world that went underwater and whose ruins have been sitting there ever since, waiting for us to develop the tools to find them and the courage to ask what they mean. In 1912, a German meteorologist named Alfred Wegener proposed that the continents had once been joined in a single landmass and had drifted apart over geological time. He called it continental drift. His evidence was meticulous. The matching coastlines of Africa and South America that fit together like puzzle pieces. The identical fossil species found on both sides of the Atlantic that could not have crossed open ocean. The geological formations that matched perfectly when the continents were reassembled. The scientific community's response was essentially unified. Wegener was wrong. There was no known mechanism by which continents could move, and without a mechanism, the evidence meant nothing. He died in 1930 on an expedition to Greenland, still largely dismissed by the geological establishment. It was not until the 1960s, decades after his death, that the discovery of seafloor spreading provided the mechanism, and plate tectonics became the foundational framework of modern geology. Wegener had been right. The field had been wrong for 40 years, despite the evidence. This is not an unusual story. It is, in many ways, the normal story of how paradigm shifts actually happen in science. Thomas Kuhn, a historian and philosopher of science, who published his landmark analysis of scientific revolutions in 1962, described a pattern he had observed across the history of multiple scientific disciplines. Normal science, conducted within an accepted framework, does not simply accumulate evidence that gradually leads to better theories. Instead, anomalies accumulate observations that the current framework cannot explain and are dealt with by being explained away, one at a time, until the number and weight of unexplained anomalies creates a crisis that forces the framework itself to change. The change, when it comes, is not gradual. It is sudden, a moment when a new framework proves capable of accommodating what the old one could not. Archaeology is currently living in the anomaly phase of exactly this kind of crisis. The evidence from the submerged sites, the Cuban megaliths, the Bimini Road, the Gulf of Cumbat complex, the Yonaguni monument is the anomalous data that the current framework for human prehistory cannot accommodate. The standard response has been the standard one: explain each anomaly away individually, challenge the methodology of each study in isolation, maintain the framework by refusing to let the anomalies accumulate into a crisis. But this response has costs. The most significant cost is the one paid by the sites themselves, which continue to be exposed to biological growth, sediment shift, and the slow deterioration of time, while the institutional debate about whether they deserve serious investigation continues. The Cuban complex has been sitting untouched for over 2 decades, not because no one has the technology to investigate it further, but because no one with institutional resources has decided that it is worth investigating. The scientist who first proposed that the continents move was called a lunatic. The scientist who proposed that bacteria cause stomach ulcers was told he was wasting his career. Both won Nobel Prizes, both were right, and both were first dismissed, because that is what paradigms do to people who challenge them. The resistance to paradigm change in archaeology is particularly intense because the stakes of the existing framework are particularly high. The story of civilization, where it began, when it began, who the first civilized people were, is bound up with questions of cultural identity, of national history, of the distribution of prestige among the descendants of the civilizations in question. Revising the origin story of civilization is not just a scientific revision, it is a cultural and political one. None of this makes the evidence go away. It simply explains why the evidence waits longer than it should for the attention it deserves. The paradigm will move. The weight of what is being found in the world's oceans will eventually force it. Before there was writing, there was memory. And before memory was committed to paper, it was committed to story, the oldest and most durable of human technologies. A story, properly told, properly valued, properly passed from one generation to the next, can carry information across thousands of years with a fidelity that rivals any written archive. Not perfect fidelity. Not literal accuracy in every detail, but structural fidelity, the preservation of the core event, the essential truth, the thing that mattered enough to be remembered when everything else was forgotten. In 2015, a group of Australian researchers published a study examining the oral traditions of Aboriginal communities along the coastlines of the Australian continent. What they found was that these traditions contained accurate descriptions of geographical events, specifically the drowning of coastal land as sea levels rose at the end of the last ice age. The traditions described coastlines that no longer exist, now lying under the sea. They described the flooding of specific bays and the submersion of specific landmarks. And when the researchers compared these oral accounts to the geological record of sea level change in the relevant areas, the match was not approximate, it was precise. The traditions were describing real events that had occurred between 7,000 and 12,000 years ago, preserved in continuous oral transmission across hundreds of generations without the aid of writing. The Aboriginal Australians have oral traditions that describe the drowning of a land now beneath the ocean, and geologists have confirmed the event they describe happened 12,000 years ago. Their stories are older than writing, and they are true. The Taino of the Caribbean carry a creation story that begins below. Their ancestors did not descend from the sky or arrive by boat from distant lands. They emerged from a submerged place, from caves beneath the water, from a world that was under the sea. This is not cosmic allegory. For a people whose ancestral homeland may have been the drowned plains of the Bahama Banks, the narrative of emergence from beneath the water is not myth. It is compressed history. The Garifuna people of the Caribbean coast maintain oral traditions describing great cities stone cities, built by ancestors of power and knowledge that the ocean consumed. The Maya Popol Vuh describes a previous generation of people, destroyed by flood, whose cities are now lost. These are not independent mythological inventions, each culture's poetic response to the universal fear of water. They are variations on the same account, told by different peoples about the same event, from different vantage points of survival and memory. The civilizations that remember the sea are telling us something that the sediment cores and the sonar maps confirm, but have not yet been allowed to complete. They are saying, "We were there. We saw it happen. We built in that place before the water came, and we survived by going to higher ground, and we have been carrying the memory of what we lost for longer than any library can record." The physical evidence asks the same question as the myths. The geology says the same thing as the stories. And somewhere between the oral traditions and the sonar returns, between the flood myths and the submerged stone, the answer to who we were before the ocean, claimed our oldest world, is still waiting to be assembled. The full story of what happened after Paulina Zalitsky reported her discovery is a case study in the particular way that institutions handle information they are not prepared to absorb. In late 2001, Zalitsky's company, Advanced Digital Communications, was operating under contract to the Cuban government, conducting a combination of commercial oceanographic work and a systematic survey of the Cuban seafloor for potential geological and archaeological interest. The discovery of the megalithic structures was not the primary purpose of the expedition. It was an unexpected finding, the kind that scientists describe, with quiet understatement, as anomalous. The sonar data was real, the ROV footage was real, the geological analysis of the stone composition was real. Zalitsky and her team brought the data to the scientific community through the standard channels. She presented findings at conferences, she gave interviews, the BBC ran a piece, New Scientist covered the story. A small number of marine geologists and archaeologists expressed cautious interest. For a brief period in 2001 and 2002, the Cuban underwater complex was discussed as the potentially extraordinary discovery that the evidence suggested it was. Then the discussion stopped. No major academic institution launched a follow-up investigation. No government agency, not the Cuban government, whose territory this fell within, and not any other government with the naval and deepwater research resources to conduct a proper investigation, committed funding, or personnel to examining the site in detail. The Geological Society of America did not commission a study. The Society for American Archaeology did not convene a panel. The site was not entered into any major underwater cultural heritage registry. It was, in the most precise sense of the phrase, left alone. Zalitsky has spoken in subsequent interviews about the frustrations of this period. She described the political complications of working in Cuban territorial waters as a Canadian researcher. She described the difficulty of obtaining the kind of serious institutional partnership that would allow for proper follow-up investigation. She described the quiet but consistent discouragement she encountered from institutions that might have been expected to be curious and were instead conspicuously incurious. The specific objections raised against her findings were methodological rather than empirical. The sonar data, critics argued, could be interpreted as natural geological formations, specifically as fault block structures created by the tectonic activity common in this region of the Caribbean. This critique has a superficial plausibility. Tectonic processes can create relatively regular patterns in rock, but it does not account for the three-dimensional structure visible in the ROV footage. It does not account for the granite and basalt composition on a limestone seafloor. It does not account for the apparent carved markings on several of the block's surfaces. The methodological critique addressed the sonar images and left the physical evidence unengaged. She found it, she filmed it, she published it, and then nothing. No major institution funded a follow-up. No government sent a submarine in any sustained, serious capacity. The most significant potential discovery in modern archaeology was met by the established world with a silence that was louder than any rejection. What has never been done, in the 2 decades since the discovery, is what should most obviously have been done: a detailed, properly funded, multidisciplinary investigation of the site. That is not a conspiracy. It is an incentive structure. It is the normal operation of institutions built to maintain and refine existing knowledge rather than to absorb fundamental challenges to it. Understanding this does not resolve the frustration, but it explains the silence, and the silence, in its own way, speaks as loudly as the discovery it is refusing to engage. Robert Schoch is not a crank. He holds a doctorate in geology and geophysics from Yale University. He is a professor at Boston University. When he examined the weathering patterns on the body of the Sphinx at Giza in 1991 and concluded, on the basis of standard geological analysis, that the erosion was caused by sustained heavy rainfall rather than by wind and sand, and that this meant the Sphinx had been carved during a period when the Egyptian climate was significantly wetter than it has been for the last 5,000 years, he was applying his professional expertise in a straightforward way. The conclusion was uncomfortable. A wetter climate in Egypt corresponds to a period roughly 7,000 to 9,000 years before the present, which would make the Sphinx several thousand years older than any accepted Egyptological timeline allowed. The response from Egyptology was not geological. It was logical in the circular sense, the kind of logic that uses its own conclusion as its primary evidence. The counter-argument was not, your geological methodology is flawed. The counter-argument was, there was no civilization in Egypt sophisticated enough to carve the Sphinx 9,000 years ago. Therefore, your geological reading must be wrong. Schoch pointed out, patiently and repeatedly, that this was not how the methodology worked. That the geological evidence of the weathering pattern was independent of any assumption about what civilization built the Sphinx, and that the appropriate response to evidence contradicting the timeline was to examine the timeline, not dismiss the evidence. The response to this reasonable point was an intensification of the dismissal. A Boston University geologist with impeccable credentials published peer-reviewed evidence that the Sphinx is thousands of years older than Egyptologists claim. The response from archaeology? Not a counter-study. Not a re-examination. The response was, there was no civilization that old. They used the conclusion to disprove the evidence. Graham Hancock occupies a different position, a journalist rather than a credentialed scientist, and therefore easier for institutional archaeology to dismiss without engagement. But Hancock's work represents something important independent of his credentials. A synthesis of anomalous evidence from across the global archaeological record, assembled into a coherent alternative framework that the mainstream has consistently critiqued without systematically dismantling. The specific evidence he cites: the underwater sites, the astronomical alignments, the mathematical parallels, the transoceanic contact evidence is real evidence. The critique of his work has largely targeted his conclusions and his lack of academic credentials rather than the quality of the underlying data. J. Manson Valentine's experience with the Bimini Road is perhaps the most instructive of these three cases, because Valentine was a credentialed marine archaeologist, because he documented the site methodically, and because his findings were dismissed, not on the basis of counter-evidence, but on the basis of the conclusion being unacceptable. The Bimini Road cannot be an archaeological site, the reasoning ran, because the accepted history of the Caribbean does not include civilizations sophisticated enough to build it at the time when it would have been above water. The conclusion determined the interpretation of the evidence. What these three cases share is not a pattern of malice. None of these researchers were persecuted or professionally destroyed in any dramatic sense. They were simply not taken seriously, not engaged with on the merits of their physical evidence, not made the subjects of the follow-up investigations that their findings logically demanded. And in the absence of serious engagement, their discoveries have sat in a kind of institutional limbo, too significant to be fully ignored, too inconvenient to be fully accepted, while the question of what is actually on the seafloor and under the sand of the ancient world remains, decades later, substantially unanswered. Science advances not through the absence of challenge, but through the honest engagement with it. The challenge to the existing timeline of human civilization is real. The evidence behind it is documented, and the response it has received tells us something important not about the evidence, but about the institutions being asked to examine it. Something is changing, slowly, unevenly, with the particular awkwardness of a field being transformed by tools it did not design and a data volume it did not anticipate. The investigation of the world's submerged prehistory is entering a new phase. And this new phase is being driven not primarily by shifts in academic willingness to engage with the question, but by the simple and democratic fact that the tools have become too powerful and too widespread to ignore. Autonomous underwater vehicles, AUVs, are now capable of operating independently on the ocean floor for periods of days, mapping large areas with multi-beam sonar at resolutions sufficient to identify features of less than a meter. A single AUV deployment can map an area that would have required months of ship time using older survey methods. The data they generate is not interpretation, it is measurement, digital and verifiable, capable of being analyzed and reanalyzed by researchers anywhere in the world. The democratization of this technology means that independent research teams with significant but not astronomical budgets can now conduct ocean floor surveys of genuine scientific quality. LiDAR technology revolutionized terrestrial archaeology when researchers applied it to the jungles of Central America. The principle using airborne laser pulses to map surface topography beneath vegetation cover allowed researchers to see through the jungle canopy and reveal the full extent of ancient Maya settlement patterns that ground-level survey had been unable to detect. The application of analogous principles to underwater environments is an active area of development, and results are beginning to emerge from test deployments in shallow water archaeological contexts. Artificial intelligence is changing the analysis side of underwater survey in ways that would have seemed extraordinary a decade ago. Pattern recognition algorithms, trained on the signatures of known archaeological sites, can now scan the raw data from sonar surveys and flag anomalous formations for human review, compressing the analysis timeline from years to days and reducing the dependence on individual human judgment that has historically slowed the identification of candidate sites. A human analyst reviewing sonar data can examine a limited area in a working day. An AI system can flag anomalies across an entire ocean basin before lunch. More of the ocean floor was mapped in 2023 than in the entire 100 years before it. And the more we map, the more we find things that do not fit. The ocean is running out of places to hide its secrets. The implications for the Caribbean are specific and near-term. The shallow portions of the Bahama Banks, the Cuban continental shelf, and the submerged coastal areas of the Yucatan Peninsula are all within the depth range of current AUV and multi-beam sonar capabilities. A properly funded, properly coordinated survey program using these tools could produce a comprehensive, high-resolution map of the potentially significant areas of the Caribbean seafloor within a decade. The cost of such a program, measured against the scale of what it might reveal, would be essentially trivial in comparison to the budgets of any medium-sized national scientific research program. The era of not knowing because we cannot look is ending. The question that remains is not whether the technology can deliver the answer. It clearly can, and increasingly does. The question is whether the institutions that control the funding will decide that the answer is worth finding, and that the truth of what lies on the Caribbean floor is more valuable than the comfort of the story that currently fills that space. The lone maverick is a romantic figure, the solitary researcher, dismissed by institutions, pursuing a truth that the establishment refuses to acknowledge. It is a compelling narrative, and, in the history of submerged prehistoric research, a largely accurate one. The people who found the Bimini Road, who documented the Cuban megaliths, who first systematically examined the underwater geography of the Bahama Banks, were mostly individuals or small teams operating without institutional support, funding their work through personal resources or small grants, publishing in journals whose prestige was insufficient to force mainstream engagement. That era is giving way to something different. Not because the institutions have changed, they are changing slowly, with the characteristic inertia of large systems, but because the tools have democratized. The same technology that allows major oceanographic institutions to conduct precision deep-water surveys is now accessible in scaled-down but still scientifically serious forms to collaborative independent research consortia. The barrier to entry for credible underwater survey has dropped dramatically in the last decade, and a new generation of researchers has walked through the opening. The Bahamas Archaeology Initiative represents one of the most systematic efforts currently underway to apply modern survey technology to the specific question of prehistoric settlement on the Bahama Banks. drawing on a combination of AUV survey data, satellite bathymetric analysis, and targeted ROV investigation of candidate sites identified through the larger survey. The project has been building a high-resolution map of the Banks's underwater topography with a detail and coverage that previous research has not approached. The methodology is rigorous. Candidate sites are identified through algorithmic analysis of sonar anomalies, ranked by statistical probability of artificial formation, and investigated in priority order through ROV deployment, with all findings documented in formats that create permanent, verifiable records accessible to the broader research community. At the University of Havana, researchers working on the cataloguing of anomalous features on the Cuban continental shelf have continued the thread of investigation that Zalitsky's original discovery opened, constrained by limited resources, but accumulating a detailed documentary record of features that extend the known footprint of the anomalous zone beyond what the 2001 survey covered. Their work has not generated the mainstream attention that Zalitsky's initial announcement briefly attracted, but it has produced a body of documented observations that any serious follow-up investigation will be able to build on. Independent research consortia, organized through academic networks and funded through a combination of small grants, crowdsourced contributions, and the increasing willingness of some institutions to associate themselves with underwater prehistory research, are applying AI-assisted bathymetric analysis to the Caribbean basin at a scale that would have been impossible 5 years ago. The datasets they are working with are vast thousands of square kilometers of sonar returns, processed through pattern recognition systems that flag anomalous formations with a consistency and repeatability that human analysts could not match. The next generation of explorers is not coming with only shovels and theories. They are coming with artificial intelligence, autonomous submarines, and satellite-resolution sonar. And what they are finding, piece by piece, is forcing a conversation that archaeology has been avoiding for 30 years. The cultural shift in this new generation of researchers is as significant as the technological one. Where earlier researchers operated largely in isolation, the new work is explicitly collaborative methodologies shared, data archived in publicly accessible formats, findings circulated through peer networks before formal publication. The conversation that mainstream archaeology has been avoiding is being forced, not by a single dramatic discovery, but by the steady accumulation of a research record that is too systematic and too well documented to be addressed by the tools of individual dismissal. In 2019, divers exploring the underwater cave systems of Mexico's Yucatan Peninsula made a discovery that was reported briefly in the science press and then vanished from public attention in the way that discoveries inconvenient to the existing framework tend to vanish. In a submerged cavern system in the state of Quintana Roo, researchers recovered human skeletal remains that subsequent radiocarbon dating placed at over 13,000 years before the present. Human beings in the Yucatan, 13,000 years ago, thousands of years before the standard models of American settlement, would allow for any significant population this far south. But the skeletal remains were not the most unsettling part of the discovery. Adjacent to the bones, in an area of the cave that the water had preserved with extraordinary fidelity, researchers found what they describe as a stone arrangement, rocks placed in a configuration that no natural cave process produces. Stalagmites had been deliberately broken and repositioned. Stones had been arranged in a circular pattern around what appeared to be the remnants of a hearth. The cave had been modified, over its full extent, in ways consistent with habitation and purposeful use. Not a temporary refuge from a storm, but a place that people had returned to, organized, and used as a meaningful space. This was 13,000 years ago, in a cave that was then above water, but is now submerged, in a region whose coastal geography at that time extended significantly further into what is now the Gulf of Mexico. The people who modified this cave lived in a landscape that no longer exists above the sea surface. They were building, modifying, organizing their world, and then the water came, and everything they built in perishable materials was lost. But the stone they moved, and the bones they left, and the underground spaces they shaped, these the ocean preserved. In a submerged cave in Mexico, they found human remains 13,000 years old, and next to the bones, stones arranged in a way that no natural process explains. 13,000 years ago, someone was here, someone was building, and then the water came. Off the coast of the Dominican Republic, a team of local archaeologists working in the shallow coastal waters of the northern coast documented, over a period of several years, a series of stone formations that do not correspond to natural seafloor geology. The formations consist of flat limestone blocks arranged in configurations that the researchers describe as consistent with the foundations of surface structures rather than the random distribution of naturally deposited material. The site has not received systematic investigation by any major institution. The researchers who documented it published their findings in a regional journal that attracted no international coverage. The sonar survey results published in 2022 represent perhaps the most significant recent development in the Cuban story. An independent research team, working with AUV-mounted multi-beam sonar, conducted a survey of an area north of the site originally mapped by Zalitsky, an area that had not been covered by the 2001 survey, and that had received no significant attention in the intervening 2 decades. The results showed anomalous formations, consistent with the pattern Zalitsky documented: rectilinear shapes, linear features, arrangements inconsistent with the local geological baseline, distributed across a previously unsurveyed area that significantly expands the potential footprint of the anomalous zone off Cuba's western shelf. And in a blue hole in the Bahamas, sediment cores recovered in ongoing oceanographic research have found a layer of sediment containing the same elevated platinum concentration that characterizes the black mat, the impact signature associated with the Younger Dryas impact event at a depth in the sediment column corresponding to approximately 12,900 years before the present. This is not a metaphor. It is a physical layer in a physical core, in a physical blue hole in the Bahama Banks. The catastrophe that may have ended the civilization is present in the archive that the civilization's homeland became. The evidence of the ending is preserved in the same sediment that may still hold the evidence of what was there before. There is a version of this conversation that ends in permanent frustration, the one where the physical evidence remains perpetually ambiguous, where every sonar image can be attributed to a geological explanation, where every stone arrangement can be called natural, and where the hypothesis of a forgotten Caribbean civilization is maintained by the weight of suggestive, but never conclusive evidence, indefinitely, as a permanent inhabitant of the space between the mainstream and the fringe. This outcome is not inevitable. It is a choice specifically, the choice not to conduct the investigations that would produce the unambiguous evidence capable of resolving the question in either direction. The standard of evidence required to confirm a pre-flood civilization in the Caribbean is not extraordinary. It is the same standard applied to every other archaeological discovery on Earth. An artifact of unambiguous artificial manufacture, recovered from a site with a documented stratigraphic context that places it in the pre-flood period, made from materials whose non-local origin can be confirmed by geochemical analysis, this would be conclusive. A worked bone tool, a ceramic fragment, a piece of shaped metal, a seed assemblage from an agricultural context, associated by clear archaeological stratigraphy with the geological layer corresponding to the period before 12,000 years ago, any of these things, found in proper archaeological context at any of the documented submerged sites, would end the debate. A legible inscription, recovered from one of the carved surfaces at the Cuban complex or from any other documented underwater site, and subject to formal linguistic analysis capable of connecting it to a known or reconstructed language family. This would not merely confirm the existence of a civilization, but provide a thread that might, over time, be used to partially reconstruct its character and its connections to other ancient cultures. Radiocarbon datable organic material, wood, bone, charcoal, found in clear architectural context at one of the submerged sites, and dated to the pre-flood period using standard isotopic methods, would provide a timeline for the construction activity at that site, with the precision that all of the other forms of evidence currently lack. None of these things require new technology. They require only the deployment of existing technology in the water, above the sites that have already been identified. The Cuban complex has been photographed. It needs excavation. The Bimini Road has been measured. It needs sediment coring at the foundation level. The Bahama Banks have been partially surveyed. They need the comprehensive AUV program that the technology now makes possible. We do not need to discover the civilization. It has already been discovered. What we need is the will to take the discovery seriously, to fund the dive, to analyze the stone, to read the inscription. The evidence is there. The decision is ours. What stands between humanity and the answer to one of the oldest questions it has never properly asked is nothing more than the willingness to look. That willingness is not a scientific question, it is a human one. It is the question of how seriously we take the evidence already in our hands, and how brave we are willing to be in the face of an answer that might change everything we thought we knew about where we come from and what we are capable of. At some point in a long investigation, the accumulation of evidence reaches a threshold. Individual pieces can be questioned, patterns can be coincidental, but when enough pieces point in the same direction, and the pointing is consistent across categories of evidence that have no logical reason to align with each other unless they are all reflecting the same underlying reality at that point, the honest response is not further skepticism, it is synthesis. Let us do that synthesis now. Let us lay the pieces out in order and look at what they describe together. The physical evidence, submerged megalithic structures, confirmed by sonar and ROV investigation, distributed across the Western Caribbean, from the Cuban continental shelf to the Bahama banks, composed of stone types, granite and basalt, that are geologically foreign to their setting on a limestone seafloor, cut with a precision measurable in fractions of a degree, bearing carved markings that have not been decoded but that bear resemblance to symbols found in ancient cultures on the other side of the world, positioned at depths corresponding to pre-flood sea levels. This evidence exists. It has been documented. It is not the product of sonar artifact or wishful interpretation. The geological evidence. The seafloor topography of the Bahama banks and the Cuban western shelf records the drainage patterns, spring systems, and erosional features of a landscape that was above water and exposed to rainfall at a time when sea levels were significantly lower than today. The Younger Dryas impact event, documented in sediment layers on 4 continents, provides both a catastrophic mechanism and a specific timeline for the rapid coastal inundation of any civilization established in the Caribbean lowlands 12,900 years ago. The genetic evidence. Pre-Columbian Caribbean and Mesoamerican populations carry haplogroups and genetic lineages inconsistent with the simple Beringian migration model markers, suggesting contact with or origin from populations in regions that conventional history places on the other side of an uncrossed ocean. The mythological evidence, flood traditions preserved in the cultural memory of every civilization that survived the end of the Ice Age, Sumerian, Hebrew, Hindu, Mayan, Taino, and dozens of others describe a previous world destroyed by water, a civilization of builders lost beneath the sea, survivors who carried the knowledge of the previous world forward into the new one. The architectural and mathematical evidence, shared construction techniques, shared measurement standards, shared astronomical orientations, and shared mathematical constants encoded in the proportions of megalithic monuments on multiple continents, distributed among cultures that the conventional framework says had no contact. At some point, you stop counting the coincidences and start recognizing the pattern. The stones, the genes, the myths, the mathematics, the catastrophe, they all point to the same place. They all point to the same moment. They all point to the same people. The stones speak. The genes speak. The myths speak. The ocean floor, where the light has never reached and the water has never been disturbed by anything but the patient settling of sediment, holds the archive of everything that came before. It has been holding it for 12,000 years with the immovable patience of stone, waiting for a moment in human history when the curiosity and the technology and the intellectual courage would converge. We are at that moment. The question is whether we will rise to it. If the Caribbean megaliths represent what the evidence suggests, they represent the remains of a sophisticated maritime civilization that flourished in the lowlands of the pre-flood Atlantic world, then the implications are not merely archaeological. They are civilizational in the most fundamental sense of the word. Historically, the revision required would be staggering. The origin of organized complex civilization would need to be pushed back by at least 5,000 to 7,000 years from our current accepted baseline. The Sumerian city-states, the earliest Egyptian dynasties, the Indus Valley settlements. These have always been presented as the first great human experiments in complex social organization, the point at which our species crossed from the purely tribal into something more organized, more ambitious, more architecturally self-aware. A maritime civilization in the Caribbean lowlands, building megalithic stone structures and navigating the Atlantic at the end of the Ice Age, would not simply predate these cultures. It would potentially be the source of the knowledge that made them possible, the teacher whose students became so distinguished that the teacher was forgotten. This rewriting is not merely a matter of adjusting dates on a timeline. It is a restructuring of the entire narrative of human capability. It means that the cognitive and organizational complexity required for monument building, astronomical observation, and long-distance maritime trade did not emerge in the late Neolithic as a relatively sudden development. It was already present, already mature, already distributed across multiple continents through an existing network, before the flood ended the network and forced each surviving branch to rebuild in isolation, carrying only the knowledge that could be preserved in memory and encoded in stone. Culturally, the implications extend to every indigenous culture that has maintained flood traditions, that has spoken of ancestors who came from the sea or from beneath the water, that has preserved in oral form the memory of a world that existed before the current one and was lost to catastrophe. These traditions have been systematically categorized as mythology, as the poetic, pre-rational responses of pre-literate cultures to natural phenomena they could not scientifically explain. If the physical evidence of a pre-flood Caribbean civilization is confirmed, then this categorization will need to be reversed entirely. The oral traditions will be recognized as what the geological evidence suggests they actually are. Historical records, encoded in the most durable storage medium available to pre-literate cultures, preserved across hundreds of generations, by people who understood that what they were carrying mattered. The psychological implications may be the most profound and the most quietly devastating. We have constructed a self-image as a civilization and as a species in which we are the culmination, the apex, the most advanced, the most organized, the most technologically capable human beings who have ever lived. The arc of history, as we have told it to ourselves, bends consistently upward, from primitive to complex, from scattered to organized, from ignorant to knowledgeable. The evidence of a forgotten civilization, older and, in certain respects, no less sophisticated than the cultures at our supposed apex, does not simply add a chapter to the beginning of the story. It restructures the story entirely. It suggests that the arc of history does not bend only upward. It bends in cycles. That human civilization has reached heights before that were subsequently destroyed, that what we call civilization is not the first flowering of human organizational genius, but perhaps the second or the third a recovery, remarkable in its own right, from a catastrophe so complete that it erased even the knowledge that there had been something to recover from. What if our entire recorded history, every empire, every philosophy, every invention we are proud of, is not the story of humanity rising for the first time, but of humanity remembering? What if we have been here before and the ocean knows it? This is not a cause for despair. It is, in the deepest sense, a cause for wonder. To discover that humanity is older and more resilient than we thought, that we have survived the unsurvivable before and rebuilt, that the ingenuity we are so proud of is not a new achievement but a recurring one. This suggests that what we are capable of reaching, we have reached before. And if the ocean took it once, we are still here, still building, still asking the questions that the stones on the seafloor have been patiently waiting for us to ask. Come back to the water. Imagine descending again, the surface breaking above you, the light fracturing and then dimming, and then disappearing entirely as the depth takes hold. The pressure increasing with every meter. The darkness becoming absolute. And then, slowly, as the lights on the ROV camera push back the black, something emerging from the sediment. Something with corners. Something with angles. Something that was placed here by hands, that moved through sunlight, in air, in a world that the ocean has since claimed completely. The first time you encounter this image, it is strange. It is disorienting. It does not fit the categories you bring to it. The second time carrying everything in this documentary behind you, Having assembled the geological evidence and the genetic traces and the mythological memory and the architectural signatures the second time, it is different. The structures are no longer strange. They are familiar. They are the remains of a civilization that built in stone, because it understood that stone is the only language that outlasts catastrophe. That chose precision, because precision is how you send a message forward through 12,000 years of silence. That built on the sea because the sea was everything their road, their food source, their trade network, their cosmological frame, their home. They had a language. We do not know it. They had a name for themselves. We do not know it. They understood the shape of the earth, the movements of the stars, the currents of the Atlantic, and they encoded that knowledge in the dimensions of stone structures that now lie 600 meters below the surface of a sea that has been keeping their secret since before any human being wrote anything down. What we do not know about them is vast. We do not know the full extent of their reach. We do not know the organization of their society, whether it was a single political entity or a loose network of related cultures connected by shared knowledge and shared sea routes. We do not know what they called the ocean, what myths they told about the sky, what music they made, what they dreamed. We know the proportions of their stones. We know the direction their structures face. We know, from the sediment that preserved the catastrophe, roughly when their world ended. We know, from the myths of every culture that outlasted them, how the survivors remembered what was lost. What we do not yet know is why the world that came after them has been so slow to look. 2 decades have passed since Paulina Zalitsky filmed a city on the floor of the Caribbean. The footage exists. The geological evidence of non-local stone on a local seafloor exists. The sonar images exist. The blue holes in the Bahamas hold, in their sediment columns, a record of the catastrophe that ended whatever was there. The oral traditions of the people who survived tell the same story from a dozen different cultural directions. The mathematical signatures in ancient stone are consistent across continents. The genetics keep finding the unexpected. The evidence is not hidden. It is accumulated, documented, archived, and waiting. We have the technology to answer the question. We have the evidence to know the question is worth asking. We have the tools to go down into the dark water and bring back something definitive, an artifact, an inscription, an organic sample in architectural context that would transform a compelling case into an unambiguous answer. The stones are still there. They will continue to be there. They have been waiting for 12,000 years, patient as only stone can be, in water that has never seen the sun. They do not need us to find them. They are already found. What is needed now is something harder than discovery. What is needed is the decision deliberate, funded, institutional, serious, to go back down, and finally, properly, ask what they are trying to say. That question is not about the civilization that built them. It is about us. And the answer, when it comes, will belong to everyone.